Alright, so I'm going to walk you guys through a presentation here on direct variation. By the end of the presentation, you guys are going to know exactly what it is. If you don't have an idea already, you'll have a better idea. And how do you know it when you see it? In a whole bunch of different forms, graphically, in a table, in an equation. And let's get started here. So, the definition, I'm going to ask you guys to write this down. So, y varies directly as x means that y equals kx. We've seen that already, something you just copied down on the slide from the Smart Notebook presentation. There's a question here that says, see any similarities to y equals mx plus b. Do we notice anything? I know a bunch of you guys are probably raising your hands right now because you notice that kx, y equals kx is equal, looks very similar to y equals mx plus b, but you're probably wondering, well, where the b is up here in the equation. Does anybody know what the value of b would be in the y equals kx if we looked at it in comparison to y equals mx plus b? Don't all answer at once now. Oh, that's right. The b value would be 0 because we're adding nothing here. There's nothing to add, so the b value would be 0. Another way of writing this is k equals yx. If we rearrange this equation, y equals kx, k equals y over x, we divide both sides by x, and we see that k equals y over x. Let's copy it. Make sure we copy all of this down in our notebooks. And this also, so in other words, we're saying that the constant of variation, k, in a direct variation is constant, unchanged ratio of two variable quantities. Let's make sure we get all this down in our notebooks also. If you didn't get a chance to copy all of it down, I've also included a copy of the PowerPoint on the wiki that you can access by going to the wiki over the internet. So here's an example of direct variation. We see in a table here x values and y values. Now we don't have a situation here that this is representative of, so let's just take a look at what's going on with the values. So x is increasing in the table, 6, 7, 8, and y is also increasing, 12, 14, and 16. Now what would it take for this to be a direct variation? Why are we calling this a direct variation? And what is the constant of variation in the table above? Well, if you look here, 6 and 12, every time that the x value goes up by 1, the y value is increasing by 2. Some of you are going to notice that. But really what we're talking about when we talk about direct variation is the relationship between the y value and the x value in each of these, like we saw in the previous slide. K equals y over x. So when we're talking about the constant of variation, we're talking about y over x. So if you notice, 12 over 6 here is 2, 16 over 8 is 2, 14 over 7 is 2. Every time you look at the y value in relationship to the x value, we note that k stays constant. Let's make sure we copy this down. I'll give a few seconds. Again, if you missed any of this or we didn't get it all copied down, I did include the PowerPoint on the wiki for you to reference at home. All you have to do is go to the wiki space and I will leave the link for you. And then there's an equation that relates the two. So here's another example in the table here. These are not in sequential order, nor are the increments the same. We go from 5/10 to 5 to 3. But we note that the value of y in comparison to x by division has a ratio 30 over 10. Again is 3. 9 over 3. Here 9 over 3. And we note again that the k stays constant. So what would the equation be? When we relate k equals y over x, usually we set an equation equal to y just like it is here. What would be the equation that represents this situation? Well, that's easy. We know that k is 3, so we just see y equals k, which is 3 times x, and it looks like that right there. Give you a few seconds to take a look. digest the information. Alright, let's move on. Oh, now we have another one here with negative values. We notice that it actually turns out to be the same thing again. So I'll let you guys copy this table, and I'll give you a few seconds to answer the question here. What is the constant of variation? Okay, so who can tell me what the constant of variation is? Oh, well, what we really want to do is look at the values in the table. Again, we're not looking at the change in x or the change in y necessarily from value to value. What was it we were doing again to find the constant of variation? Anybody? Anybody? With a hand? Oh, thanks. Alright, so, yep, just explain to the class. Well, seeing as how I can't hear you, I'll just tell you that what we want to do, again, a reminder, we want to take the value of y, divide by the value of x, and every entry in the table, every ordered pair here, because remember this is an ordered pair, it can be written as I can't figure out how to do this. Oh well, it can be written as x comma y, like that, with the parentheses, and those are points on a plane. And what we want to do is, again, just look at the values y over x. So we see that in each case it's 1/4, and the k stays constant, and we're looking at 1/4 x as the equation. So now, what is the constant of variation for the following direct variation? Let's take a look. Now, if I was actually there, I'd be asking you guys to raise your hand and answer, but let's just see. Just write down the answer, copy the table in your notebook, and write the constant of variation next to the table, and if you can, try to write the equation that represents the situation. I'll give you guys a few seconds to do that. Alright, hopefully all you guys found out that the correct answer is -2. We see that dividing -8 by 4, -16 by 8, 12 by -6, and -6 by 3 all result in a quotient of -2. And again, remember, a quotient is the result from division. So whenever we divide y by x, that quotient is called the constant of variation. And if it's the same for every single pair we have of x and y values, we know that it is a direct variation. This also alludes to something that we talked about before. Does anybody know what it is? We also looked at something where all of these ratios are the same. If these ratios are the same, what can we say about the situation? That's right, we can say that it's proportional. So because all of these values are in the same ratio, we can say that we have a proportional relationship, which is basically saying that we have a direct variation, or that y varies directly as x. And we'll see that language come up soon. So here we say, is this a direct variation? If yes, give the constant of variation in the equation. So I'll give you a few seconds and write that down. Alright, we see that it is, because 6 over 4 is 3 over 2, and so is 12 over 8. These are all the same, so we see that the equation is 3 over 2x. And that's how that would work there. Again, you could have taken any of these and realized that they are all 3 over 2, so that's the equation. We'll try another example. I'll give you guys a few seconds to take a look at the table and write the equation down and the table down in your notebook. Again, just a reminder, when I come in on Thursday, I will be checking your notebooks, and your notebook is worth 10 points. And you should have all of this done. Like I said, if you missed something or didn't copy something down, this PowerPoint will be on the wiki for you to review if you need to in order to complete your notebook. Or if you have any trouble with the homework, it'll be there for your reference. This one here is a yes again. Why? Because all of them simplify to the same ratio, 5/2, the y values divided by the x values, and the equation would be y equals 5/2 x, or 2.5x if you put it in decimal form. We'll skip the third one. Actually, let's do this one here. What about this one here? Is it a direct variation? Give you guys a few seconds to copy down the table. So if we take a look at the y values in comparison to the x values here, we see that no, because the k values are different. If you look here, 5 divided by 15 is not the same as 26 divided by 3, which is not the same as 75/1. It's not the same as 150/2. Now, if you looked at these two here, 175 and 150, you would notice that the k value is the same, but that does not match up with the other values in the situation. So now let's look at these tables. Which of the following is a direct variation? I'll give you a few seconds to take a look at that and respond accordingly. Alright, what do we think the answer is? A, B, C, or D? Hold up one finger for A, 2 fingers for B, 3 fingers for C, and 4 fingers for D. Alright, so those of you guys that put up one finger, you guys are correct, and those of you with B, C, or D that were the correct answer, we'll talk on Thursday about why those are not examples of direct variation. So look at this. This is a different way to put it now, given that y varies directly as x, and y equals 28 when x equals 7. Find x when y equals 52. How are we going to do that? Well, we already know that x is 7 and y is 28, so we want to know what the value of x is when y equals 52. So what exactly should we do here? Well, because we know that y varies directly as x, they're telling us that we have a direct variation. So if we have a direct variation, we can just take this 7 and that 28 and set up a ratio to y over x and find that our k value, our constant, is 4. So if that's the case, then we plug it back into our equation and have y equals 4x, y equals kx, and k is 4 here. So if k is 4, then we see that 52 equals 4x, and now we just need to solve for the x. We divide both sides by 4, and we see that x equals 13. So that's how we're going to do this. If we know that we have one point and we know it's a direct variation, we can basically set an equation here. Another way we could do it was setting up a proportion. We could do 28 over 7 equals 52 over x and solve that this way. That's basically the same thing, because we said that a direct variation indeed was a proportion in general. Now, I'm about to run out of time on the video, so I'm going to close this one out and start a new one. So just click on the next video on the wiki and we'll finish up this presentation.